All right, so just overviewing some things here. We're starting chapter 2 today, and the other video had a stem and leaf plot, but I just wanted to show you that in here we have an example of a pre-calculus class scores on the first exam from smallest to largest. So 33, the stem would be 3, the leaf would be 3. 42, the stem would be 4, the leaf would be 2. 49, you just put a 9 for the leaf here. And if you have a 100, then the stem is 10, the leaf is 0. So that would be a stem and leaf plot for the 2-digit scores. Well, the last one is 3 digits, I guess. Now, if you have something like this, where you have decimals like 1.1, 1.5, 2.3, all the way to 12.3, then in your stem and leaf plot, your stem would be the number on the left of the decimal, your leaf would be the number on the right of the decimal. So like here, 1.1 would have a stem of 1, a leaf of 1. 1.5 would have a stem of 1, a leaf of 5. 2.3 would have a stem of 2, a leaf of 3. 2.5 would have a stem of 2, a leaf of 5. 2.7 would have a stem of 2, a leaf of 7, and so forth. When you get to 12.3, your stem is 12, your leaf is 3. Note that we don't have any numbers in the 7s, 8s, 9s, or 10s, so or 11, so they're all just blank there, no numbers. So you can do a stem and leaf plot if you have decimals like that. Now, a back-to-back stem and leaf plot would be if you're wanting to compare two data sets. So here we have data on the president's age at inauguration, and then this is going to be their age at death on the bottom. So we can see Washington was inaugurated at age 57, died at age 67. So if we want to do a back-to-back stem and leaf plot, we would put the tens digit in the middle, and then we would have the left side would be age at inauguration, the right side would be age at death. So like Washington, when it was inaugurated, was 57, so we would go to 5 and then the 7 right there. John Adams was 61 at inauguration, so we would go to the 6 and then the 1 right there. Now, Washington passed away at 67, so then you would go to, for the age of death, you would go to 6 and then you would go to the 7. So this just allows you to compare data using what we call a back-to-back stem and leaf plot. This textbook refers to it as a side-by-side stem and leaf plot. I've also heard of it as a back-to-back stem and leaf plot. Here we have a what's known as a frequency polygon. Now, a frequency polygon is similar to a histogram, except you're going to make a line with it all. So here we have the number of times a teenager is reminded, and then the frequency. So 0, 1, 2, 3, 4, 5. So at 0, we have a frequency of 2. 1, we have a frequency of 5. 3, we have a frequency of 14. And you just plot 4, we have a frequency of 7. 5, we have a frequency of 4. And then you just connect the dots like that. And that is an example of a frequency polygon. I've also seen frequency polygons where you extend it down to make it close in on the x-axis, but this textbook doesn't do that. So the last one is a bar graph, and I know you've all seen bar graphs before. And here we have, if we want to do a bar graph on the race or ethnicity of students in U.S. public schools for the class of 2011, and percentages advanced placement exam population for that class, and percentages of overall student population, we can create a bar graph. And the bar graph would just, well, we've identified each race by a number here. You don't have to do that. You could just put the race down instead of the number. And then this bar graph would be percent of AP examination. So you can see that 1 is Asian, that's 10.3. Number 2 is Black or African American, that's 9. Number 3 is Hispanic or Latino, that's 17, and so forth. And you just have a bar graph. Bar graph's a little bit different than a histogram in that the bars aren't actually touching. So that's a bar graph. I'm pretty sure you've all seen those before. And sometimes bar graphs is the best way to depict the data.